Welcome to Hartman Math. This is lesson 10.1, lines. We're going to start with the definition of the inclination of a line. So, the inclination of a non-horizontal line is the positive angle less than pi, or 90 degrees if we're thinking degrees, measured counterclockwise from the x-axis to the line. So for a horizontal, it would just be 0. For a vertical, it's from the horizontal counterclockwise to the line, so pi over 2 or 90 degrees. And then here it's that theta. And over here again, it's not the negative, it's the positive. So the formula, if our line is not vertical, that slope or inclination is the tangent of theta. So we can find that by using arctangent. So find the inclination of the line x plus y equals 4. Well, let's take a look at graphing it first. So if we were going to graph it, we could do the find it by intercepts. So set y equal to 0. The x-intercept is 4, 0. The y-intercept is 0, 1. Our slope, tangent of theta, is going to be negative 1/4. So if we do inverse tangent on the calculator, let's say we're doing degrees, it's going to give us the negative angle. We want the positive angle, so we're going to add 180 to that. And we get approximately 166 degrees. Checkpoint, find the inclination of the line. 4x minus 5y equals 7. Pause here until you've got it. So you might want to solve this one for y, get it into y equals mx plus b form, where the slope is then 4/5, inverse tangent. (38.7 degrees is the inclination. We can also find the angle between two lines. So if we've got the angle between the first line and the x-axis is theta 1, and the angle between the second line and the x-axis is theta 2, then theta is going to be the difference between theta 2 and theta 1. So it turns out that the tangent of theta is going to be the absolute value of the slope of the two lines divided by 1 plus the product of the slopes. Find the angle between here and here. So we're probably need to start out by finding the slope of each line. So if we solve this one for y, we're going to get y equals 1/2 x something. So our slope here is 1/2. Our slope here, negative 5/4. So tangent of theta is going to be the absolute value of the difference between those two slopes, negative 5/4 minus 1/2, divided by 1 plus the product. So we're going to need a common denominator here. So negative 7/4, and then 1, that's going to be minus 5/8. We're going to get complete evaluation there. Tangent of theta is going to be 14/3. So now we can go inverse tangent of 14/3 to get theta. Theta is approximately 77.9 degrees. Checkpoint, pause here as you find the angle between those two lines. As you go through the work, you should get about 85 degrees. All right, the distance between a point and a line. So if we have a line and a point somewhere else, right here, then the distance between the line and the point has to be measured perpendicularly. Shortest distance, that's defined to be the distance. And we can calculate that distance by taking the absolute value of a times, and a comes from the equation of the line when it's equal to 0, a times the x coordinate of the point plus b times the y coordinate of the point plus c, absolute value, divided by square root of a squared plus b squared. So, example number 3, find the distance between the point 3, 1 and 4x minus y is equal to 5. All right, so we can take a look at what that looks like on a graph. You may want to solve this one for y. Y is equal to 4x minus 5. So that would tell us what the y-intercept and the slope is. Here's our point. But as far as using the formula, we're going to need to get this equation into this form. So we need to have it be equal to 0. So 4x minus y minus 5 equals 0 is going to allow us to use this formula. So the distance is equal to, we said, 4 times the x-coordinate, negative 1 times the y-coordinate, and as we said, minus 5, the minus 5 absolute value divided by 4 squared plus negative 1 squared. So we've got 12 minus 1 minus 5. Take the absolute value, so 6 divided by the square root of 17. That's going to be about 1.46 approximately. As an exact value, 6 divided by the square root of 17. All right, checkpoint, pause here as you find the distance between this point and this line. Don't forget, get this equal to 0. Exact value, 12 over the square root of 10, that's approximately 3.79. Example number 5, let's see if we can apply that. Let's find the distance of, find the area of triangle ABC. We've got the coordinates here. So step number 1, choose a base. Choose any base that you want to choose. Kind of like this one for the base. Okay. So once we choose the base, we need to write its equation. So we need to find the slope. We do that by rise over run or the slope formula. That would be first. And then we could use point slope form with either one of these points to write the equation. So the slope is up 1, right 2. And then if we use this point, y minus 2 is 1/2 times x minus 6. Distribute. If I don't like the fractions, it wouldn't matter to have the fraction, but I could fraction bust this and then get everything on one side so that it's equal to 0. So if we get everything to the left side, negative x plus 2y plus 2 is equal to 0. So we've got our line where the equation's equal to 0, ready to use the formula. So there's our equation. Step number 2, find the height. So we need this distance right here. So the height is the distance between that point and that line. So we could use the formula. So absolute value, negative 1 times the x-coordinate plus 2 times the y-coordinate plus c, all in absolute value, divided by negative 1 squared plus 2 squared square root. So negative 1 plus 6 plus 2, 7 over the square root of 5. I'm sorry, 9. Error there, 9 over the square root of 5. That's our height. So we've got our height. Last thing we need for area of triangle, since its area is 1/2 times base times height, is we need the length of the base. And that should be pretty easy. That's just straight distance formula. So that's step 3. Find the length of the triangle's base. Let's use the distance formula. So distance formula is going to tell us that square root of 125. That simplifies to be 5 root 5. So the area of the triangle is 1/2 times the base times the height. Probably should be number 4 there. So we do that. Root 5 divided by root 5 is going to cancel. 9 times 5 divided by 2, 45 halves, 22.5. That's our area. And that's it for today. I'll see you next time.